All right. Well, welcome back, folks. Yeah, hopefully everyone had a good weekend and you're able to get some rest weekend. Okay. I want to start out by just saying that it was my fault on Friday. I need to know my audience a little bit better, and that is, as we went through the sample problem on Friday, where we had to use the very first kinematic equation to get some work done. There was a step in there where we had to do conversions, okay, and we had to do a conversion. And as I was working through the problem, the automatic assumption I made is that everyone's had this, you've done it before, but there's quite a few of you who have not taken chemistry, have not done conversions yet, have not taken physics. I don't know if you have had the opportunity to do conversions in your junior high classes, but that was my fault. I didn't know my audience. I wasn't more aware of my audience, and so I went ahead and did the problem, and I worked through it fairly quickly. And so I apologize for those of you who felt a little bit overwhelmed on Friday, and you had to try to figure out what I was doing in order to get the work done, and what the conversions are in order to get that done. And so what I decided to do is to do a quick revision of the kinematics notes. What I'll do is I'll post these notes for you. I'll post these conversions for you online. I'll post it on Google Classroom for you. That way, then you can use this as a quick primer on conversions. Now, for those of you who've had me before and you've taken class, you've had conversions before, the discussion here will be very simple, very straightforward. I think the work you won't have to worry about it so much. But who knows? Maybe it'll be a good review for those of you who've had it before. Okay, and so I'm going to take the period today to talk about conversions. I'm going to talk about it really quickly. Conversions are absolutely essential in the work that we do in science. Okay? Because in science is a data-driven it's a data-driven field. Science and scientists require data. We require data in order to make sense of the world around us. Data is absolutely important. The way we collect it, the way we interpret it. Okay, and so without the data that we collect, without the data that we use, science then is just all guesswork. It's just anybody's guesswork. Nothing can be shown to be correct. And so what we need to be able to do is we need to be able to collect the data. And we need to be able to interpret it. Part of that interpreting process is to do what are called these conversions. And so conversions essentially then it involves then changing one unit of measurement to another unit of a measurement. Now measurements, and I should highlight this for you, measurements then, all measurements involve two critical parts. All measurements involve two critical parts. Okay? And these critical parts then are the number. All measurements must have a number and a unit. Okay? All measurements must have a number and it must have a unit. What the number does is it describes, so a measurement is a description of the physical universe. Okay? The physical universe, almost every part of, no, I'm sorry, let me take that back. Every part of the physical universe can be measured, okay? In different, can be measured, okay? There are aspects of the physical universe that we can't measure, obviously, if we are talking about spiritual aspects, if we're talking about emotional, those are all real parts of the universe, okay? But when we talk about the physical universe, the universe that we can experience on a physical level, that we can touch, that we can see, that we can hear, sense. So the part of the universe that we can sense, okay, we can measure that part of the universe. Okay, we should be able to measure that part of the universe if we have the correct tool. Now, if we don't have the correct tool to measure it, then we have to rely on what are called qualitative data. And so there we just provide a description, a word description, but we can't assign a number. Okay, so the measurements then are what we call quantitative data. We can take all parts of the universe, physical universe, and describe it either in qualitative terms, that is just using words, or quantitative terms using measurements. And that's what we want to make sure we're going to focus in on here. Because with measurements, then we have a tool that we can use to decide then how big or how small. If, for example, the length of a room versus the length of a ruler. Okay, so we can take a ruler and we can measure out each one of those lengths. Okay, but that length then has a unit that we can define them. Then the unit then will describe what is being measured. So the number describes how big. Okay, so the number here describes how big the measurement is, the size. Okay, okay. And the unit here then describes then what's being measured, what is measured. Okay, the aspect of the unit that's being measured. Okay, so it provides a description of what is being measured. Number, how big, unit, description. Okay, so the conversion then, when we do these conversions, what they do is they allow us to change one measurement into another measurement. And that's exactly what we're doing here. So when we do conversions, what we're doing is we're changing from one measurement to another. We're changing one measurement into another. And that can be done. Okay. Now understand, as we go through this, we're changing the measurement. We're not changing the size of the measurement. Okay. We're changing how we describe it. So with conversions, then basically what we're doing is we are changing the description of the measurement itself. And that's what you want to keep in mind. Okay, we're changing the description, which means then we're changing the unit here. Okay. Now, with that said, the number will change here as well. The number will change here because as you change the units, and we'll see then that there are arbitrary assignments that we make to it. As we change the units, we will also be changing the number that's associated with that unit. And so the conversions then basically changes the description of the measurement, description of the measurement, but as a part of that description, okay, we're going to change the unit, but the number also has to follow because every measurement has a unit and a number that is unique to it. Okay, all right. So some of these conversions are pretty straightforward. They are absolutely straightforward. Where we're going to do some simple ones today, where you're going to look at me and you're going to say, why do we have to go through this process that I'm going through in order to get the conversion done? We can just shift the decimal point. You can do it in your head, and I would tell you if we had a chance to meet, that you're absolutely right. Some of these conversions, you should be able to shift the decimal point one way or another. You can do this mental math and you can get it done. And for those conversions, absolutely, I would highly encourage you to do it in your head, do the mental math and get it done. However, some of those conversions are very complex. And so you cannot just do it in your head. And so you need to have then a systematic method. You need to devise then a systematic method in order for you to get that conversion done. If you don't have a systematic method and you're doing it randomly, folks, you're going to have a very hard time with these conversions. Okay? And so conversions, just like with any math problems, folks, you have to have some technique. You have to have some method that you can use in order to get the work done. If you don't, then it becomes very difficult. Okay? And so the method that we're going to use to carry out these conversions is what's known as dimensional analysis. The dimensional analysis is actually a larger field, larger method that we use. It's an analysis tech tool that we can use to do more than just conversion. We can use dimensional analysis, for example, to determine whether our answers are correct or not. We can use dimensional analysis then to determine then whether an equation that we're using is a correct equation or not. Dimensional analysis is a very powerful tool that we can use in science. I'm not going to spend much more time on dimensional analysis here. You'll get that for those of you who haven't gotten it yet. You'll get it in your later science classes. But it's a very powerful tool that I just want to focus in on one aspect of dimensional analysis, and that's going to be this conversion. So we can use dimensional analysis to do conversions as well, and that's what we want to do. Now, do understand this, folks. For those of you who've had trouble doing the algebra problem in the past, okay, those algebra word problems, I've always told students that if you can learn how to do conversions, if you can set up these conversion factors that I'll teach you in just a moment, you can do many of those algebra problems, because a lot of those algebra word problems are basically conversions that you have to do where you're changing one quantity into another quantity. Okay, so they may not be measurements, but you can do one quantity into another. Okay, so learn this and it'll help you down the line. Okay, but for now, let's go ahead and let's take a look at these conversions and what they are. Let's continue on and talk about it. Okay? The dimensional analysis is basically an analysis of all the physical quantities in the universe. Okay? Everything in the universe has certain aspects about it, okay, that that occupy a certain dimension in space. Okay, and so, for example, everything in the universe has a length, and we can break up the parts of the universe into three basic parts. Okay, three basic parts of length. So everything in the universe has length. Everything in the universe has a length. Everything in the universe has a mass. Okay, and so, and then I'm sorry, everything in the universe is encompassed in time. So these three are what we refer to as the three basic dimensions of the universe, which means then everything in the universe can be defined then in terms of its length, in terms of its mass, and in terms of the amount of time that it occupies, the amount of time that is encompassed, that encompasses it. Okay, so we all have a certain length. We have a certain height. We have a certain width. Okay, we all have a certain mass associated with this, and we all have a certain amount of time that we can exist here on Earth. Okay, and this is true for everything in the physical universe. Okay, so we can the dimensions then, the dimensional analysis then, so these are the basic dimensions of the universe. Okay, of the universe. And so these dimensions then, folks, again, what we're going to define then as a dimension is a measurable physical quantity, the measurable physical quantity of the universe. Now there are other dimensions. Don't get me wrong. There are other dimensions. I'm just saying that these are the basic dimensions from which other dimensions can be built. Okay? Other measurable parts of the universe can be built. So, for example, speed, how fast something moves, is length over time. The volume of an object is the cube of the length. Okay? The density of an object is the mass over length, length cubed. Okay? And so all other properties, all the other physical properties of a particular object in the universe can be built off of these three. Okay, so the dimensions then are physical quantities that can be measured. So when we talk about physical dimensions, these can be measured. Okay? We can, so when we do this analysis here, we're going to look at the ways that we can describe these dimensions. Okay? And so we're going to examine units. So each one of these dimensions then have a unit associated with them. So for example, length has the unit of foot. We use that imperial unit here in the United States. We in science and everywhere else in the world, we use meters. And so what we're going to do then is we're going to examine the units. The dimensional analysis is essentially looking at the units that describe each of these basic physical parts of the universe. Okay? And then what we do then, so we're going to examine the units. We're going to take a look at the units first. And then what we do then is we will use what are called ratios. Now, you have to make sure you remember what ratios are. Okay? Ratios then, remember, is basically a comparison. It's a fraction. It's a comparison we do of two different quantities. Okay, two different quantities. And so we're gonna when we do dimensional analysis, we're gonna make use of these ratios here, and specifically we're gonna make use of what are called unit ratios. Okay, so you got to make sure you remember what unit ratios are. If you don't, this is from unit ratio. This is from algebra, and I think everyone here in class has had algebra before. So if you have not yet, please make sure you come by and ask about it. Okay, so we're going to take advantage of what are called unit ratios. Okay, and I'll highlight again what these are as we go through. But again, make sure you come by and see me with extra. Okay, and then finally, if you know how to multiply fractions, if you know how to divide fractions, dimensional analysis makes use of that. the math is going to be simple. The math is going to be simple. I think with dimensional analysis, it's trying to set up the problems. That's going to be a little bit more challenging, and that's what we're going to spend time working on. Okay. All right. So let's go ahead then. Let's continue onward. Okay. All right. So the center point or the centerpiece of doing these dimensional analysis involves then a conversion factor. Okay. A conversion factor is a ratio. It is a ratio that is made up of equivalent measurements. Okay, so equivalent measurements then, and make sure I want you to make sure you understand. Then, when we talk about these equivalent measurements, the equivalency here is absolutely arbitrary. Okay, these are arbitrary assignments that we make. Okay, and so understand this: the conversion factors that we're going to use here is a ratio. These ratios are a ratio of equivalent measurements. Okay, so what's an example of an equivalent measurement, you may ask? Okay, well, for example, let's take a look at this here. Okay, 60 seconds in 1 minute. We all know that. Okay, we all have accepted that fact, and it's a fact to us because we've accepted it. But understand this: it's a fact only because is it a fact because nature recognizes it? Does nature recognize increments of 60 seconds? Nature does not. Okay. The reason why we refer to this as a fact, that there are 60 seconds in 1 minute, is because we as a species have decided then that if we take this unit of time that we refer to as a minute, okay, and we've decided how we're going to keep track of this 1 minute of time, we've decided then that we can divide up that 1 minute into 60 equal parts, and each part then we refer to as a second. If a dog could talk, folks, if a dog could talk, a dog would tell you that he or she knows nothing about a minute, knows nothing about the second, would not accept our definition here of seconds and minutes because it doesn't exist for that dog. Okay? And so this assignment here of 60 seconds in 1 minute is absolutely arbitrary. It's arbitrary because we as a species have chosen to use this connection here and these defined values, okay, to measure out our time spent here on Earth. But in this life, then, we have decided to break up our time into different types of increments. And so again, those are completely arbitrary assignments. So too is this next one, okay? And so if you take a look at this next one here, 12 inches in a foot, folks. Okay? Now, I really despise this particular measurement here because it is more arbitrary than we need to make it. The empirical system is a fairly, it's an extremely inconsistent system of measurement because there's no rhyme or reason to it. Now, not that there is rhyme or reason to any of this, okay, but at least hopefully, if we're going to be arbitrary about this, that we try to set up a system that has at least some type of consistency to it. The empirical system has no consistency. So I'm gonna step off my soapbox now, and I'm gonna start preaching about the flaws in the empirical system. But do mind you though that this shows us then how arbitrary it is. Okay? So the fact that there's 12 inches in a foot, folks, nature does not recognize any of this at all. Okay. Furthermore, and the history of the empirical system is a fairly arbitrary one. You know, the foot, as it was defined back in the day in England, was basically determined by whichever king was living at that time. Okay, and so you can imagine then the chaos that would ensue if the king dies and then a new king steps in and the new king has a different size foot. All of the land that you bought prior, all the land that you wanted that was measured out in the foot of the old king now would change. Now, if the new king has a smaller foot, then your parcel of land is going to be smaller, even though they measured it out using the foot. If the new king has a larger foot, then you gain more land. So you can imagine then how chaotic that could be if that was how they defined the foot. Now, obviously, what they did then is that they chose, and as time progressed, to define the foot in a more predictable way. They called the 12 inches. Yeah, but then still, with that said, then from there, then you have to remember this 1 to 12 ratio. You have to remember the two numbers associated with this particular measure. The 3 feet in a yard, and so forth. Okay? Those numbers then are more difficult to remember. Those are very difficult to remember, especially as you go in, as you get older like me, and you start forgetting things more. Okay? But also because there's no consistency. in that at all. Okay, and so step in the metric system. Okay, the metric system is also arbitrary. Don't get me wrong about this. It is also an arbitrary system. Okay, but at least there is consistency in it. The consistency comes in the ease in which we can convert between one unit to another. And we'll pick up with this a little bit more tomorrow, and I'll finish up with the discussion of conversions tomorrow. But with the metric system, then we are using base 10 base 10 numbers to relate one unit to another. And so even though the relationships then are again arbitrary, okay, they're easier to remember. Relationships are easier to remember because they're less arbitrary. Okay? Again, they are still arbitrary, but they're less arbitrary. All right. So with that said, what I'd like you to do then is please make sure you watch the video. So about this, make sure you watch the video. And what I'd like you to do is make sure you understand what conversions are, and then I'm not going to ask you to do any background work on this. I'll teach you what you need to know here, but make sure you understand what the conversions are, because tomorrow what we're going to do is we're going to work through some of these problems here. Okay, so nothing due today. This is kind of new, and I kind of as a last minute thing, I've included in this primer here. And so you don't have it on your notes, but I will shoot it out to you this afternoon, okay? And then have that for you, okay? And so make sure you take a look at the notes, okay? Make sure you take a look at the notes, and then we'll go over it tomorrow, okay? All right, folks, have a good day, and I will see you tomorrow.